Hey everyone. Yeah, happy to follow up Karina's great presentation there, but talking about a little bit of different monoliths. So yes, this is massive Terraform imports and why you should avoid building monoliths. Um, and this talk is kind of geared towards Terraform practitioners, especially those of platform teams, but hopefully anyone that's using Terraform will find it valuable. And so if you've worked with Terraform, you've likely had to import an existing resource into your Terraform state. But what makes it a massive import? Let's find out. And if you haven't guessed already, this is going to be a don't do what I did kind of talk. Cool. And so, yes, my name is Joe Bell. I'm a senior software engineer on the cloud acceleration team at Twitter. My pronouns are he, him, and I'm a light skinned male with kind of shoulder length brown hair sitting in front of a tan wall, a tan and orange backdrop. And I wouldn't be a very good Twitter employee if I didn't plug Twitter. So you can follow me at JBF Bell, mostly for Simpsons memes and Wisconsin sports updates. And I also just want to plug Twitter has a new communities feature that has an infrastructure as code community, and I encourage you all to join. So monoliths are appealing, and permissions are hard. So why are monoliths appealing? Well, as a platform team, you're often aware of the kind of the compact complexities of the solution you're trying to offer your customers, especially as it relates to security and dealing with super user credentials. And rather than build deal with the distribution of these credentials, a monolith allows you to sort of lock down just one thing, and that is exactly what we did. We wanted to offer essentially a Terraform module that our customers could instantiate new instances of that would allow them to self-service their Terraform environments. And in this example, it's specific to GCP. So basically, we created a Terraform Enterprise Workspace. Customers could create new copies of this module that we created, and the output of the module would be it would be a service account, and that service account would have all the right permissions for their scope to allow them to build the infrastructure in GCP that they needed, and it would also make those credentials available to them in their Terraform Enterprise Workspace. And before we go on, I just wanted to go over some context, just some nuances of GCP that I sort of needed to understand where I'm going with this talk. And they relate to IAM policies in GCP and Google Workspace. So GCP has a cascading IAM policy hierarchy such that the top level entity being an organization, followed by folders underneath that, projects, and then inside of projects, there are specific resources which also have their own IAM policies, and each resource inherits from all of its parents. So any policy, any IAM grant that's applied at a parent level will be inherited by the child. And the policies on each of the resources have a maximum number of 1,500 assignments. And so, for example, if you were to assign one role, such as storage object admin or something, to two principals or two accounts, that's two assignments. And the exact reverse, two roles to one principal is also two assignments. Until recently, Google Workspace, formerly known as G Suite, did not have an official Terraform provider. And also in our company, there was a bit of an ownership divide here. G Suite or Google Workspace has to deal with Google Sheets, Docs, Gmail, etc. And so this was owned by our IT department, and it was not a part of our. And so because this was not an official provider at the time when we were creating the solution, we did not include it in our deployment. So let's get into the incident. We broke the monolith. Terraform was more popular than we had expected. We experienced exponential user growth from our internal customers, but One day, the applies started failing, and we couldn't create any new service accounts. So in this module, there are some shared resources. And in this particular case, it was a single Google storage bucket, which most teams needed to have their service accounts be able to access. On the slide here, oh, sorry, I keep forgetting to advance both sets of slides. Cool. So on the slide here, you can see that this is the Google Terraform Google Storage Bucket IAM member resource. And if you're familiar with Terraform and GCP, there are typically three ways in which you can make an IAM policy change. And in order of their authoritativeness, there's an IAM policy, an IAM binding, and an IAM member. Um, we're using member here because it's useful inside of a module because as you're instantiating new copies of the module, you don't necessarily have to be aware of the rest of the policy to be able to make the change that you want. Member is sort of the plus one approach, like add me as well. And it turned out that we were not the only team that had been granting access to this particular storage bucket in this way. And so those of you that I'm sure have put it together, we reached that 1,500 IAM assignment limit. So what did we do? Well, immediately we identified a few accounts which we just knew were testing accounts or weren't in use anymore, and just sort of remove their access to the bucket just to push the customers which had experienced that failure, push their changes through. But we needed to sort of halt any new account creation until we could mitigate this. And the fix was known to us. We had always sort of known that the long-term fix was to use a group. So rather than having each individual account be granted access membership to this bucket, they could be granted membership to a Google group, and then that group could be granted the access, and they would inherit all of the access that their group membership provides them. Um, and so why didn't we do it this way in the first place? Well, as I sort of said before, we didn't own Google Workspace, and we didn't have the proper admin access to be able to add these external emails. So a service account in GCP is essentially an external email. It's not, in my case, it's not a twitter.com email. It's it's a essentially Google email address. And so we were not able to add those to Google Groups. And as I said, the Google Workspace provider did not exist. So we would have had to have an external process which added these members to the Google groups. And at the time, we did know that the G Suite, there was kind of an unofficial G Suite provider. And so I think we had sort of were hoping that we would have enough runway to just go ahead without it. Um, but things were still broken now. We needed to do more mitigation. So there was an existing tool that which we did have access to, which could add these accounts that we were creating to the proper groups that we needed. And I say groups plural here because we took this opportunity to identify this pattern where we were using this IM member assignment for things which were broad, and took the opportunity to correct it across the board in this module. Um, and we're actually able to use an open source tool called HCL to JSON just to kind of parse the configuration and identify which accounts needed to be added to these Google groups. And so that was the first stage, was identifying the existing accounts and adding them to the correct groups um, to get the same access that they had in the first place. The next step was to add a flag to the module, which defaults to false, which if it was true would add the IM members um, as it had been prior to the flag. What the effect of this is that the next time we run Terraform apply, it would notice all of the IM memberships that these accounts had and remove them. So it would say that now it's default to false. I should remove all of this access. And that worked great. We were able to remove about 300 accounts from the bucket, but we still had the same problem. So it's effectively like hitting snooze on the time bomb. We For any new accounts, we would either have to migrate them individually or come up with a long-term solution. Luckily, we had gone through the process of obtaining the proper admin access to be able to instantiate the Google Workspace provider in our module, and we were able to use this the Google Workspace group member resource to add all of the new members to um, the correct Google groups. And so that's what this block on the screen does, is it just says add, similar to I am member, just add me to the group as well. However, the key caveat of this block is that it does fail if the member is already in the group. So doing some math, we needed to import all of those existing group members. So we had migrated about 300 service accounts to 6 groups across all of those IM member use cases. Comes out to about 1,800 imports in a single workspace. Um, an additional complexity with these imports is that we could not use HCL to JSON. There was some introspection that we needed to do into the Terraform plan. Things such as the accounts that were going to be created were generated. We didn't know the exact import path, and so if I show you the, oops, sorry, I'll get to it in a second, but I'll show you the import statement. But there is a tool provided by HashiCorp which does allow us to introspect uh, HCL and Terraform plans, and that's Sentinel. So if you're not familiar with Sentinel, it is a policy language that you can integrate with Terraform Enterprise. And its intended purpose is to be able to check your Terraform configuration, and then you're able to write policies and rules and either deny or approve Terraform configurations from being deployed. However, in this case, I was using it to run that Terraform plan. And another feature of Terraform Enterprise is you can get the Sentinel mock, which is essentially like what the JSON output of a Terraform plan looks like. But you can get the Sentinel mock and then use that to test your Sentinel policy. So the ideal workflow would be you write some Terraform code, generate a Sentinel mock, and write your policy so that you could approve or deny configuration changes. But what this is doing is it is trying to extract relevant information for building these 1,800 import statements. And so taking a look at what the expected output is might be a little easier. Oh, so this is what a Terraform import statement looks like this is just the generic Google Workspace group member import pulled straight from the provider docs. But so basically you can see it's Terraform import, and then you need um, the path to which you're importing. And then it's the syntax of groups, group ID, members, member ID. And the member and group IDs are not relevant or not readily available to non-admins. And so we did not have direct access to be able to fetch those group or member IDs. And so this is what the Sentinel policy is trying to pull out. So you can see it's a JSON map of group ID, and then inside of that is a map of or is a key value of the email address of the service account, and then the address within the Terraform workspace that we would be importing to. So just to step back a little bit, this is what the output of this Sentinel policy is. Cool. And so at this point, essentially, I'm about a third of the way through the battle. We know the group IDs, we know the group email, and we know the import address. But we don't know the member IDs. And that's because in Terraform, it's expecting to add them and generate that member ID. And so not being an admin, I can't fetch this from a UI or anything like that. And also there's 1,800 of them, so I should probably figure out a way to automate it. So what I did was I created a Terraform data workspace. I don't know if that's an official term, but essentially it's a workspace that doesn't create anything. It's just using the credentials to output some data. And so that's what you see here is it's pulling in the metadata from the specific groups. And then for each group, it's pulling in all the metadata about the current members. And then it is outputting a value which is similar to the previous output, but the difference is so it's still group ID to member email, but rather than import address, it is the member ID in the group. And so with that, we now have enough information to um, stitch it together. So I was able to use I wrote a Python script to just kind of coalesce those two objects, those JSON outputs, and generate those 1,800 import statements, which all look something like this. Um, you can see, so it's Terraform. The change directory is just I was developing this solution in a different location, so just want to make sure I'm specifying the exact workspace in which I want to import into, and then the import statement, and then the import address. It's quoted. That the quotations there and the escaping of the quotations is required for accessing those keyed or for each values, and then the group ID member ID syntax to import that, and then that's imagine 1,800 of those. And that's all well and good, right? We've got a solution. Well, why should you avoid building monoliths? The point of my talk. But what is especially painful about a monolith in this situation? Well, first is that Terraform statement manipulation via imports is tricky. Should really lock down any other use while you're trying to manipulate state in a Terraform workspace. Which essentially means we needed to cause an outage. We couldn't take any new requests. We had to kind of block the workspace while it was in maintenance. And the other thing that's painful about this is within the same workspace, you cannot batch imports. And if I'm wrong about this, please come find me in the in the comments. But yeah, you cannot have a batch import in a Terraform workspace. So all of these 1,800 imports need to be run synchronously. Um, and in addition to just these imports, these 1,800 imports, that's 1,800 resources. We had other resources for each of the modules. So even with um, even with some tricks of trying to skip refreshing on the workspace, each of these import commands was taking somewhere between 15 and 45 seconds. And if you do the math, the best case scenario for 1,800 imports take about 7.5 hours, and the worst case take about, sorry, I keep forgetting to switch these slides, take about 22.5 hours. And we were a little bit longer than that. We took about 24 hours, and that's because a few times this process would fail for whatever reason, and each time that the process failed of running these import scripts, I would have to kind of redo all of those tasks. So I'd have to go through and generate the Sentinel mock, parse it with the JSON output, update the group membership, coalesce them, and then create a new import script. So each time it restarted, there was a little bit of downtime, or a little bit of reconfiguration. And other than this particular incident, you do feel the pain of a Terraform monolith essentially at every step of the life cycle. When you've reached about 4 to 5,000 resources, your Terraform plan slows down, your apply slows down, everything slows down. So imports are by far the slowest, as they can't be batched, but you feel it at all aspects. And another downside is that all of these teams, which are otherwise independent, become dependent. So as you can imagine, a 24-hour outage for any team that's trying to do anything new in Terraform is frankly a bummer. And the reasoning is that Terraform doesn't have that kind of if it fails, it fails. It doesn't have a partial success. You can maybe get lucky if your resource gets applied first, but generally it's kind of a pass fail. Cool. And with that, I hope I've shed some light on why you should avoid monoliths. And if you do find yourself in a situation where you need to do a huge Terraform import, we'll have some tools to get yourself out of it. And also just PS, we're hiring. If you're interested in solving cloud problems at Twitter, come see us. Thanks.